So, dear friends, dear colleagues, for me it is a great pleasure to be here in this library. I remember the time when I was here and studied quantum mechanics. And now I would like to show you the result of these studies. So, subject of my talk looks as strange. So I would like to show you some relation between qubits and universe. Qubits very tiny. It is very, very small system. And how this very small system, such as a qubit, can be related with the universe. So my goal of this talk is just to show some relation. At least I will consider also the universe. And I hope we see this relation between very large system as our universe and very small systems such as qubit. Okay, let me try to change. No. Okay. Of course, I would like to start from classical bit. Before I explain in more details what is quantum bits, let me start from classical bit. So classical bit, it is heart of classical computer. We use classical computer, so important elements of this device is just classical bit. What is quantum bit? Quantum bit is an important element of quantum computer. Of course, this definition is not definition. Okay, what is quantum computer? Quantum computer is device that use quantum properties for calculation. Also very strange definition, but nevertheless it is true. And when I say about quantum computers, of course I would like to mention Feynman, Richard Feynman. Richard Feynman was one of the first scientists who just proposed to use quantum computer for quantum simulation. You can find here the paper written by Feynman, and section 4 is entitled directly Quantum Computers, Universal Quantum Simulators. It is about how many, more than 42 years. So 42 years ago, Feynman said about quantum computers and proposed to use quantum computer for simulation of quantum system. So let us know what happened. Okay, thank you. Here is presented quantum computer. You can see classical one. Classical one is here. It's classical computer, and on the screen you can see one of the example of real quantum computer. You find here many wires, many tubes. It is a very complicated system. Virus is used for manipulation with qubits, and tubes is used for cooling the system. Very small temperature, maybe similar to millikelvins. So it is very complicated system, not simple, not such as a classical one. So main problem is just this problem with cooling of the system to very small temperatures. Okay, now let us consider what about some what is a classical bit. Classical bit is very simple to understand. Classical bit, it is physical system which have two stable position. For instance, it can be, let me use also bottle for explanation. What is classical bit? Suppose you have this position for bottle and some another position for bottle. Let us, it is two stable position. So when bottle is here, that is 0, corresponds to 0. And the another position of this bottle corresponds to 1. So we have realization of classical bit. I can consider another example, for instance, can be classical arrow on my hand. Also can realize classical bit. When my hand is up, it is 0. When my hand is down, it is 1. So it is also realization of classical bit. So here there is many classical bits. So we can organize, of course, classical computer using all of us as a bits classical bit. Here I present for you in more details what classical bit is. So suppose you have some another example. You have two boxes, up box and down box. So when particle is presented in the top box, so it corresponds to 0. The another possibility, particle is presented in the bottom box, so it corresponds to 1. So it is also realization of classical bit. You can consider many possibilities for realization classical bit. And let us write more information about classical bit. So I use such a representation for classical bit. When particle is here, I write here 1. This particle is here, not here, I write 0. So here in the bottom box, we have no particles, therefore I write here 0. Okay, the similar I write here. In the bottom, this box, we have 0, we have no particle, and here we have particle, so 1. So I write this classical bit as a vector with two components, 0, 1. So I have classical vector with two components, 0, 1. This realization of classical bit, and 0 corresponds to this vector, 1 value of classical bit corresponds to this one vector. Very simple system. And I would like to say here that classical system can be in the state 1 or in the state 0. Here is very important this or. So we can have classical bit in the state 0, or we can have classical bit in the state 1. It's just very important moment of this system. We cannot have classical bottle in this position and in this position at the same time. It is impossible. When you have classical bottle, it is impossible to have this classical bottle in two positions at the same time. But now, when we consider quantum bit, we find that it is possible to find quantum bit in two positions at the same time. It is called superposition. It is called a superposition, and it is really how very small particle, behavior of very small particle. When you have a very small particle or quantum particle, and quantum particle have two possibilities, so then this particle takes at the same time these two possibilities. It is called superposition or superposition principle. So let us consider then quantum bit, and quantum bit means that when quantum bit can be in position 0, it corresponds to this vector, or can be in position 1. So quantum bit can be in position which corresponds to 0 and 1 at the same time. We have here superposition of two possibilities. Superposition of two possibilities just create quantum bit. Superposition is very, very important for quantum bit. Classical system. We can now remember the following very important moment. Classical system live using the principle or. Quantum system use the principle and. It is just difference between classical and quantum system. Okay, I think I explained what quantum bits is. So when we write this classical bit as a vector, classical bit here, so classical bit can be only in this state described by this vector, or only in this state described by this vector. And here we allow to add these vectors. Adding these two vectors, we have just superposition. Okay, let us consider the next slide. Next slide. No, next slide is here. Next slide is here. So let us consider two bits. Here we have more interesting situation. So possible position for two classical bits written here. So particle is here. Here it is 0 state for one bit, 0 state for second bit. So we have 4 different possibilities for classical bit. Okay, but when we consider quantum bits, two quantum bits, you remember that quantum system can be at the same position at the same time. So we have superposition principle, and here I write the superposition for 4 possibilities for 2 bits, and state of 2 quantum bits in general can be written as superposition of these 4 possibilities. It is just superposition of 2 quantum bits. Let us next slide. And here appear very interesting feature. This is called entanglement. It is impossible in general to write state of quantum bit present as the state of one bit and the state of another bit. Let me omit details of this very interesting feature of quantum world and quantum behavior. Okay, but I only mentioned that here appear very interesting, very new feature of two quantum bits, which is called entanglement. And Professor Zizkovsky told about this feature, very nice talk about this entanglement. So I omit details about quantum entanglement. Now let us consider n arbitrary classical bit. And here we obtain also very many possibilities. How many possibilities we have for classical bit? Each classical bit can be in 2 states, 0 or 1. So you can easily calculate that when you have n classical bit, you 2 in power n status of this classical bit. So many possibilities for states of n classical bit. Okay, and now what we obtain when we consider n quantum bit. In the case of n quantum bit, we can have superposition of all these possibilities. So n quantum bit can be in the state with the superposition of all possibilities for classical bit. The superposition principle right here. So this sum contains 2 in power n states. So sum contains huge number of terms. One state, let us look once more, only one state, which is right, I do not hear psi, contains in this sum all these possibilities for classical bits. Very important, in fact, for quantum computation. Okay, let us next slide. Now I present what means classical calculation and what is quantum calculation. Of course, in very short presentation. So classical calculation, we have some input, some initial state of classical information. Then we have classical computer, we have output, some result of calculation. Very simple. You know about calculation on classical computer. For instance, when you want to find minimum of function of these binary variables, x take only two values, 0, 1. So how many you must to perform calculation? You must perform 2 in power n calculation. In order to find the minimum of this function, you must to find the value for each possible values of variables. You must to calculate very much, perform to very much calculation, 2 in power n. Now let us consider quantum calculation. Quantum calculation, input for quantum calculation is psi. Psi, it is superposition of all these possibilities for classical system. As a result, quantum computer at the same time make calculation over all possibilities for classical state. Only one calculation which can be done by quantum computer calculate at the same time 2 in power n numbers at the same time. So here, in order to, when you very smart and you find algorithm for calculation of minimum, you can calculate this minimum only for one calculation instead of 2 in power n for classical case. Here you can find the very possibilities for quantum calculation in compare to classical calculation. Okay, and now because my talk is about qubit and universe, here I would like to make some calculation, very simple calculation related with universe and classical computer, universe and quantum computer. So let us compare. Let us write once more state of n quantum bits written here. It is superposition of all possibilities for classical bits, for n classical bits. And what we find here? We find here a very interesting relation. Relation is the following. Let us suppose, in general, this coefficient C written here, it is complex number. But let us consider a very simple situation when this coefficient in this superposition, it takes only two values, 0 or 1. 0 corresponds that this term is not presented in sum. When C is 1, it means that this term is presented in this superposition. Okay, so we have n quantum bits, which is represented by a sum, in general contains 2 in power n terms here. So how many coefficients C we have? 2 in power n. But all these coefficients take only values 0 and 1. It means that C, it is classical bit. So how many classical bits we need to represent this quantum state psi? So in order to describe n quantum bits, we need 2 in power n classical bit. It's a very huge number. Let us consider one of the powerful quantum computer, Osprey. It is computer IBM company, 22 year. So number of quantum bits is about 400, more than 400. Let us calculate how many classical bits we must to have in order to simulate using classical computer this quantum state, quantum state. It's very simple, 2 in power r, n, or this calculation, very huge number. Very huge number. And let us consider now. Here I presented this number as 1 and 0. You find that it's huge number of these zeros here. And half year ago, IBM company presented also some new computer which contains 1,000 qubits, more than 1,000 qubits. Here we also can calculate how many classical bits we need in order to simulate using classical computer this quantum state. You find this very, very huge number. And let us calculate this number with our universe. Let us calculate how many nucleons we have in our universe. It is very simple problem for student, for pupil, for all of us. You can find the mass of our universe approximately. You know the mass of nucleus. So you divide mass of our universe on the mass of nucleus. You find the number of nucleus in our universe. So number is this written. So when you compare these two values, you find the following result. Suppose that we consider our universe as a classical computer, and nucleus plays the role of classical bit. Suppose all our nucleus which we have in our universe is classical bit. Then what we find that even all our universe will be classical computer. It is impossible to using this classical computer to simulate quantum state of quantum computer which is created by IBM Condor. All our universe as a classical computer cannot simulate the state of this number of qubits. It's just explained why quantum computer can be very powerful. Because when we consider quantum computer deal with state of quantum bit. So one calculation which we can consider it on quantum computer, it is at the same time calculation with this number of classical bits. It's absolutely impossible to perform on classical computer. So it can be explained why quantum computer is so powerful. But let me consider next problem. So you can ask the question, when we have such powerful quantum computer, when we cannot calculate everything, why? Problem is that in fact we have not logic quantum bit. It is physical quantum bit, and main problem is just related with the coherence. Main problem is the coherence. We have influence environment on quantum computer. It leads to decoherence, and decoherence leads to errors during quantum computation. It is main problem for now. Okay, here is explained what is decoherence. It is loss of coherence. Very simple definition. Decoherence, it is loss of coherence. So when decoherence leads to errors during quantum calculation, of course it is bad. So what is answer? How to solve this problem? So it means that we need error-resistant algorithm. We need algorithm which is error resistance plus, of course, Plus, of course, it was better when it is better when we have computers with longer time of coherence. And now many companies just try to solve this second problem related with the coherence. Conclusions. I would like here only once more to stress the following important moment. Classical world, principle of classical world is or. When we have two possibilities or many possibilities, you can use only one possibility or some another possibility or some another possibility. It is classical principle. Quantum principle, it is and. When you have quantum system can be in possible states at the same time. We have superposition principle. Or in quantum case, and. It is very important two principle for classical world and for quantum. Okay. I write here once more what is quantum computer. Quantum computer is device that use quantum properties for calculation. It is called quantum calculation. And art of quantum programming is in using superposition and entanglement to achieve quantum supremacy. Okay, and knowledge of quantum mechanics is needed to be quantum programmer. Why? Because quantum computer is device that use quantum properties for calculation. So in order to use these properties, you must know quantum mechanics. So enjoy this quanta, and thank you for your attention.